So in the past, when we asked you to find area of a triangle, the formula we used was the area is equal to 1/2 base times height. This formula right here. Meaning that you would need to know what the height on a triangle was. Well, now today there are two more ways that you can find area of a triangle when you do not have the height, it's impossible even to find the height. One way is when you're given a triangle. Oh, let me move this button before I turn it off. When you're given a triangle that is a side angle side triangle, which we learned last class that is a triangle that has a side. They give you a side and another side, and also the angle between. So this is a side angle side triangle. When we have a side angle side triangle, we can apply, I know it breaks this up into three separate formulas, but these are the exact same formula. Why does it keep, okay. All that this formula means is the area is equal to 1/2 times one of the sides they give you, times the other side they give you, times the sine of the angle between those two sides. That's all that this means. And they just change up the lettering. So, this is 1/2 a times c times sine of b. That's the angle between a and c. And this is 1/2 a times b times sine of c, which is the angle between a and b. I don't really know why these notes keep breaking this up. It's the same exact formula. Okay. So here, we'll do this example. Find the area of triangle ABC, given that A is 6.05, B is 9, and angle C is 45. So as always, we need to label our triangle. It doesn't matter where you put these letters, as long as your sides across from the angles are consistent. So it gives us side length A, which is across from angle A, is 6.05. And it gives us B, which is across from angle B, is 9. And then this is angle C, this angle right here is 45 degrees. So here we do definitely have side angle side triangle, SAS, meaning we can now apply this new angle or this new area formula. What it states is the area can be found by multiplying 1/2 times one of the sides it gives you times the other side it gives you times sine of the angle between, which in this case is 45. We pull out our nice calculator. 1/2 times 9 times 6.05 times sine of 45. And we should get, what'd I do? Minus, no one yelled at me. There we go, 19.25. And what is our unit? It's inches. For sure it's inches. But also remember, area is not one-dimensional. Area is two-dimensional. It's a length and a width. So it is our unit squared. Area is always squared. Yeah. And that's it. That's all there is to it. You're just multiplying 1/2 times one of the sides it gives you, times the other side it gave you, times sine of the angle between. Notice it would have been impossible here to find the height. Like there was no way that I could have found the height. So that's why we use these formulas. All right. Thumbs up. What's up, Trinity? Is your calculator in degree mode? Mm-hmm. Anytime you ever get an answer different from me while doing trig, it is most likely that your calculator is in radians. Okay. Um, I think that I'm going to skip over number 2. I'm going to skip over the practice and I'm just going to go right to the application. This problem states, find the area of a regular octagon, 8 equal sides, 8 equal angles. Whenever it says regular and then a type of polygon, it means that all sides are equal, all angles are equal. Inscribed, which the word inscribed just means it fits perfectly inside. Basically, the angles will touch the edge of the circle. If you remember from geometry, which you probably don't, but we did have such a thing as inscribed angles, and it was always the inscribed angles were in the side of the circle, is how I did it. But anyway, and the circle has a radius of 9 inches. So the first thing I'm going to do is I'm going to draw a circle. I didn't want the circle right there. Oh, okay, whatever. Let it go. So now I'm going to do, and I'm kind of bad. So what I'm going to do is I know octagons have 8 sides, meaning the top portion of the octagon will have 4 sides if I think about it. And it having 4 sides means that there will be a point. There will be a point at the top, and there will also be a point at the bottom. And there will be angles on the sides. And then it having 4 sides means that halfway between those points, there's also going to be a point. You can draw the octagon however you want to draw it, but I just thought maybe I didn't how it. See, and then you kind of have like somewhat of a good octagon versus like I always seem to like I just can't do it. I don't know why. I can't do it on its own. All right. So now we're going to put the information it gave us. The only number it gave us was that the radius of this circle is 9. Now I'm going to draw the radius, but I'm going to make sure that I'm drawing the radius to an angle on the octagon because really what we care about here is the octagon. We're trying to find the area of the octagon. So this radius being 9 means that if I were to create another radius to an angle in the octagon, I now have a triangle. And if I break this into 8 different triangles and I find the area of one of those triangles, I can then know the area of the total octagon by multiplying that triangle by 8. So that's like the process of going. Now, great. I have side lengths. That's awesome. What information do I also need? Angle. How do you get it? You have Y360. Right. We know that a total circle is 360 degrees. So at that central angle, that center dot that I drew, where the radius is kind of shooting off, that's called a central angle. In total, that central angle all the way around is 360 degrees. And we know that there are now 8 central angles. I broke up that main central angle into 8 different parts. So you would do, to get your angle, 360 divided by 8. And what do you get? Yeah, or you could know that, 45. So then I now, because I know this angle, I can now apply my formula because this is a side angle, side triangle. 1/2 of the two sides that we have on the triangle times sine of the angle between them. So we have 1/2 times 9 times sine of 45, 28.64. Now I'm done. Why not? I'm glad that usually people don't like say no so quick. Right, it's only one of them. I'm not trying to find the area of a single triangle. I'm trying to find the area of the whole octagon. So there are 8 triangles. I need to multiply this triangle by 8. And you should get 229.1. And our unit is inches squared. Fixing this one just a little bit. Are there any questions on this problem? Okay. So now, and I almost kind of apologize because why is this in this unit? I don't know. I think it's because they're like, oh, well, you're solving for area here in this previous part. Might as well just introduce this new formula for area here as well, even though it has nothing to do with trig. So I apologize. But I'm going to introduce another way that you can find area of a triangle when you are given 3 sides on a triangle, no angles at all. So you're given 3 sides on the triangle. Again, on a side triangle, you would have no way of finding the hypotenuse. You can't use the normal formula. There, way back when, and it was derived from using the distance formula, just like our law of cosines was. I'm not going to show you that proof. But this is called Perron's formula. And the only, not even the tricky part, but the only part would be tricky maybe if we were in class because you would have to memorize this. But in the formula, there is something called the semi-perimeter, which is just taking all 3 sides and dividing it by 2. This is termed the semi-perimeter. So everywhere in our formula where we have a little s, that refers to the semi-perimeter. So in these problems, the first thing that we have to do is we have to find that semi-perimeter, which is just taking the 3, well, being lazy over here. I always, when there isn't a picture drawn and it's talking about some shape, you should always draw the picture. Which in this case, it's really, really not needed. But it does show you that this is a side triangle, meaning I can apply Perron's formula. So now that I have the triangle drawn, I can find the semi-perimeter by taking those 3 sides, adding them together, and dividing by 2. So we have 5 plus 7 plus 9 divided by 2. 10.5. Could I have done that in my head? Probably. Do I want to right now? No. Then we just take that number and use it in our Perron's formula for the area of a triangle. So we have 10.5. Well, wrong way. 10.5 times the semi-perimeter again, minus the first side that they gave us, times the semi-perimeter minus the second side they gave us, times the semi-perimeter minus the third side they gave us. And I just have the ability here to plug this all in my calculator. Anytime they're asking for area and you're having to use Heron's formula, they are not going to expect you to leave it in simple credit. Right? Heron is a person. I have no idea who it is. But I know that Heron's formula has been around for a long time. So he's very, very good. So we have 10.5, 10.5 minus 5. Could we do some of the simplification prior to putting it in the calculator? Most likely. Am I being lazy right now? Yes. 17.41. And you're done. That's it. Oh, I didn't leave myself any room. And then our unit, as always, because this is area, is inches squared. Well, oh, they do say inches here. Oh, shoot. Wasn't even a person. This hero formula. Oh, interesting. Are there any questions? What's my cloud turn into a box? All right. Thumbs up if you can do this on your own. Thumbs down if you want me to do the practice. I'm still going to do number 3, but I'm asking about the practice. Thumbs up if you can do this. Thumbs down if you want to see the practice as well as the information. Okay, I see all of them. So I'll just move on to the application. Now, honestly, this looks like a big problem. It's not. Let me read it real quick. Jim and Barbara are looking at a plot of land to purchase. The owner describes the plot as a little more than a fourth of an acre. With Barbara stationed at a corner of the plot, Jim starts at another corner and walks a straight line towards her. Using his electronic distance measuring device, they then shift corners and Jim measures again until they have recorded the dimensions of the lot. What is the approximate acreage of the lot? So here clearly we see we have 2 triangles. We can use Heron's formula on these 2 triangles and then add them together to find the full area here. Now I did label these just to keep them straight, triangle A and triangle B. So I'm actually having to use this Heron's. So first, in both, I need to find the semi-perimeter, which is where I will take all 3 sides, divide by 2. And on this first triangle A, I'll just tell you that's 150. So the area is going to be the semi-perimeter 150 times 150 minus the first side, 150 minus the second side, and 150 minus the third side. Again, I am being so lazy. Oh well. I always. Okay. So yes, we should get 4,184.54. Then, unfortunately or fortunately, we have to do the same thing again, this time for B. So we do 81 plus 112 plus 115, divide by 2, and I believe we get 154. Maybe I should do this in a different color. it doesn't want to go. So then I am again doing the formula of Huron 154 times 154 minus 81 times 154 minus 112 times 154 minus 115. Oh, every time. Four two nine point. Oh, if I round to the hundredths, then I make it 2. I'm just gonna go out 4, I think. But really, this number doesn't matter. I think if you notice, Math Excel recommends that you literally pull down from the calculator. You always put at least 4 decimals. Are A and B mixed up? I don't think so. Are they? No, no. Okay, but then I'm not done. I'm trying to find the full acreage here. So I need to add these two together. So I do this plus, I can now notice I updated my calculator. 8475.74. Now, I'm done. I should circle this and move on. Yes. The whole thing about this whole thing. Most of this was really straightforward. I'm like, you have to apply a formula. Whoop-de-doo. Now, though, we have to make sure that we're not leaving it. We have to make sure that we're reading this problem correctly. It's asking for the approximate acreage of the lot. So we need to take what we just found was feet. We need to take these feet and we need to turn it into an acre. So we do exactly that. 1 acre is worth 43,560. So you just divide to see how many acres fit into that many feet. And I believe you should get, well, I guess I did. Divide by, what was it? 43560. 0.1946, so 195, which is, whoops, which is really close to how much of an acre? 0.2, which is in fraction form. What is 0.2? A fifth. This is about a fifth of an acre. My acre. So this guy is definitely trying to dupe them over. He says it's a fourth of an acre, and they're like, no, it's a fifth. It's even less than a fifth of an acre. Are there any questions on either of these areas? Oh, he was an engineer. It's a the. It's a the. Fifth of an acre. Does it need to be there? Probably not. All right. So I hope that this was pretty light for you guys, and I'm not just assuming that it's light for you. I do, if I do that often, I'm like, oh, it's easy, and then later on they're like, you always do that, and it was. So I apologize if this wasn't easy for you, but I hope it was light. Any last questions about area? The hardest part about this is It's not even really that hard, but you need to recognize, okay, what triangle are you given? Side triangle or a side triangle? And you'll have to know which formula needs to be applied to, which you won't have to memorize this because you have your notes. You guys are looking out, by the way. Right up here. What happened to my calculator? It says 1 acre. 1 acre is 43,560 square feet. So they so nice. I wrote it wrong? No, I didn't. Yeah, my side looks kind of wonky, but it definitely. Look at this. Oh, look at that. Definitely a five. Guys, you're so picky. There you go. Any other questions?